So thank you all for joining us on this lunchtime webinar as we explore the future of connectivity in the workplace. My name is George. I am the head of business development at Connection Solutions. And I've been working with Tim and the team since the beginning of the year. In fact, I'm going to be moderating the discussion today. You have to excuse my slightly hoarse throat. I'm doing my best impression of Tom Waits. Unfortunately, got some rather festive lurgy to be dealing with. So we're going to kick off with a quick, very brief overview of Connection Solutions. Really what we do, clear as in the name, call it the Ron Seal approach. We help businesses and individuals with poor mobile challenges and network speeds. We work with leading technologies such as Cel-Fi, which is we're going to be discussing today, and indeed Starlink. And really, whether you're in the square mile in downtown London or you're on top of a mountain in the Highlands, it's our mission to design bespoke solutions which are robust and which are fit for purpose. And if you'd like a bit more information about what we do, you can pop over to our website, connectionsolutions.net, for more information. In terms of housekeeping for today's webinar, there's not a huge amount that you need to be aware of. The discussion will be between half an hour and 40 minutes, and there will be some time for Q&A at the end. There is a Q&A box at the bottom. If you'd like to ask a question, then please feel free to do so. If it's relevant to where we're at in the discussion, then I will endeavour to ask it of our panel at that moment. Otherwise, I'll be asking them at the end. I'm also recording it today, so if you have to pop out for whatever reason, then I'll be sure to be sending you a link by way of follow-up. So, without further ado, I'm going to ask the panel, our wonderful speakers today, to briefly introduce themselves. We're going to start with Colin. He is the Senior Account Manager at Frequency Telecom. Colin, you're going to give us a little bit more. Colin does have George Bell also written this as his name on the screen, but I promise you this is Colin Giles.
Thanks, George. Hi, everybody. Yes, it's Colin Giles here. I work for Frequency Telecom. We are the distributor of mobile accessories to industry and channel partners, and that includes, as part of that, the Nextivity suite of Cel-Fi products. And within Frequency, I focus on the Nextivity products, and I've been doing that for nearly 6 years now.
Hi, I'm Tim Rogers. I've been a network and telecoms engineer for about 15, almost 20 years now. Started off as a rigger climbing towers, went into radio frequency work, building wireless ISPs, designing DAS. I kind of worked on every kind of telecom system out there, from POTS, plain old telephone systems, right through to fiber. So yeah, a lot of my recent work in the last few years is building fiber ISPs, and yeah, always working on mobile phone booster DAS's connectivity solutions through all of that. So yeah, that is my background.
Great, thank you very much both. So on that, Tim, I'm wondering if we can kind of set the scene, kicking things off by giving us actually a bit of an overview of how mobile signal boosting actually works, perhaps without delving too much into the technicalities of things, and maybe with a couple of examples of people you've worked with over the last couple of years.
Yeah, so I mean, essential mobile connectivity is your mobile phone talking to the carrier networks, which tend to be the cell towers, microcells. We fit systems that basically have an antenna on the roof to pick up the external signal, amplification and boosters, and then it distribute that around inside the building or the area where connectivity is needed. So for the Frequency and Cel-Fi equipment, it's called an on-air repeater. Picks up the external signal level, brings it into the building, and it's a two-way device. So your mobile phone is then talking through our system out to the carrier networks, and vice versa. It's going through from the carrier networks to your mobile device. We've done any number of different industries we've worked in. I mean, hospitals, NHS. So Harrogate Hospital's a good example, something that me and Colin have worked with. But also, Portsmouth Hospital, London, University College London, done universities we've worked with, lots of offices, lots of banks, traders, key importance, mansion houses, high net worth individuals, London mansions, basements. I'm trying to think of sort of a unique place we've done. I think there was a chicken farm we once did. I think that's one of the stranger locations.
I think that counts.
Yeah.
Colin, coming to you, can you give us a little bit of a sense of what actually makes Cel-Fi so unique in addressing these connectivity challenges? What makes it such a market leader?
Sure. Cel-Fi is one of the very few Ofcom license exempt solutions on the market for boosting or repeating mobile signal. In 2018, Ofcom introduced the license exempt criteria, which meant that effectively, if you comply with the legislation, then you could market your products as license exempt, and only Ofcom license exempt solutions could be deployed in the market without operator approval. And to date, Cel-Fi is still one of the very few Ofcom license exempt solutions in play. And it's probably the only solution that's capable of deploying robust and resilient solutions in the larger enterprise buildings. So Tim mentioned things like hospitals, hotels, large distribution warehouses. Cel-Fi is really the only license exempt mobile booster that's capable of performing at the required levels within those size of buildings. Also, it's relatively quick to install and deploy. So we're talking, weeks or a couple of months as opposed to years. And arguably, compared to some of its competitive solutions in the bigger DAS type scenarios, it's quite a cost-effective solution to deploy. So really, from its legality, its timeframes, and its cost, it sets it apart as a unique solution.
Okay, excellent. Thank you for that. Thank you for that, Colin. So, Tim, imagine, picture me as the director of an SME. I'm a business owner. I have poor signal in my office, but I have got very good Wi-Fi. Do I actually need a solution for boosting my mobile signal as well?
Well, I mean, if Wi-Fi works for you, that's great. I mean, we don't want to ever sell a solution to somebody that they don't need. But in the case of Wi-Fi, the solution for mobile phones on Wi-Fi is Wi-Fi calling. Wi-Fi calling is mixed. If it works for you in your location, great. Personally, I found it a real mixed bag. My last house, we had a fiber connectivity to the house. I was the only user in the house. And it worked, but it always disconnected the call within sort of 10 to 15 minutes, and you'd have to reconnect it. If you're ever moving from an area that you're on Wi-Fi calling, you're trying to go outside and connect to the mobile carriers, it will always drop. There's no sort of smooth transition between those, smooth handover, unfortunately. Yeah, the reliability of the Wi-Fi calling seems lesser. I mean, if you're handing between different APs within an office or a building, again, it will also cut out. If you're sat at a desk and you're not moving, that it can work, but it also means you've got a single point of failure. So if no one can call, if you're relying on a mobile phone for calling, you lose your Wi-Fi. It means no one can contact you, no one can email you. Teams is down, Slack is down. So you've got very much a single point of failure, and that's where we can come in to give a bit of resilience, a bit of diversity to that connectivity, basically. Wi-Fi is brilliant for everything. We're not going to knock it. Like, all of us use it all the time. We know that it is very good.
It's
also,
hard to make a case against Wi-Fi, isn't it? Let's be honest.
yeah, I mean, we're all using it right now, I'd say. So it's
Mm-hmm.
it does work. It is good.
So this, I think, I addressed to both of you, and you've both got, almost unprecedented industry experience between you. What would you say are the major things that have changed over the last 20 years, but particularly in a kind of forward-looking context, and what this means for what people and business owners particularly can expect? I'll come to you, Tim, first on this one.
I mean, in telecoms for me, initially we were putting in 100 meg radio links to people's businesses and to building, and that was seen as, a gig link was seen as being a huge amount of data that people would need, and then that's being outstripped. I've got a lot of 10 gig point-to-point radios on rooftops, and they're all maxed out. We're doubling them up to 20 gig point-to-point radios, and that's just not enough capacity. In my fiber ISP world, a lot of my street cabinets have got 200 gigs of connectivity per cabinet, and we're starting to see that's actually it's actually reaching a limit now. You've got 100 gig east and west, and that's maxing out. So it's just that data usage. 20 years ago, when you're using a mobile phone, no one expected to be able to browse the internet on their handset. Really, it was all about mobile phone calls, and probably 80% of our users now it's interested in, they're trying to make phone calls, but the expectation now is that they can also have high data bandwidth to the phone. You expect to be able to watch an HD video on your phone at any location. So it's that data, going through the phones, going through the networks, that is just grown hugely. I mean, I used to run a wireless ISP in Birmingham, and we had 500 meg backhaul for about 50 customer network, and that was fine. Whereas now I've got a lot of business customers that are on 10 gig connection into their office, and there's an expectation that they can pull a huge amount of data down. So that's the big thing that's changed, and the expectation of connectivity everywhere. Everything is online now. Office 365, SharePoint, there's Slack, there's Teams, there's WhatsApp. We communicate to engineers, we send them data all the time on their phones, we're expecting them to respond in real time to that. And that's that's the real difference I've seen in it. For better or worse, we're connected all the time now. Colin, I don't know what you're seeing as being the biggest shifts for you.
Yeah, I think sort of adding to that, I think it's the movement over the last 10 and 20 years to the mobile phone, the mobile device being the primary device for connectivity. I think there's, in industry particularly, I think there's less reliance on desk phones or fixed handsets as there was maybe 10, 15 years ago. So people have adopted within industry the mobile phone as the device for contacting customers, communications internally. You mentioned the NHS, and there's obviously been quite a lot of deployment of Cel-Fi across the NHS, and I think there's within the NHS we've seen a decline in the use of proprietary, so pagers, deck phones that would have been the standard 5, 10, 15 years ago, and there's more onus on the mobile phone for communication within staff, and obviously having good cellular coverage for patients and visitors as well. And obviously, as a result of that, NHS buildings, other types of buildings, suffer from poor mobile connectivity and being able to use the device of choice. So I think we've seen that the move to the mobile phone as the main device. We've also seen, particularly in the last 5 years, really since I've been working in the in-building coverage with frequency and activity, is the introduction and the deployment of applications and other devices that actually rely on mobile connectivity or the mobile signal. So not just the mobile phone needing signal to make phone calls or or use a data network, but we've seen other applications come onto the market, be deployed, where it's an important part of the operation and function of these devices, such as EV chargers, smart meters, payment machines, lift auto dialers, have all come into the market, and they need mobile signal to operate. And again, in those environments, if they're installed in underground floors or in corridors of the building where the mobile signal isn't good, then they're not able to operate and function as effectively as possible. One might say it's this sort of we're seeing a tangible evidence of the Internet of Things being deployed, needing to be connected. So it's we see, or I see going forward as well, more applications coming on, more devices relying on good mobile connectivity to provide for the client and the building and such.
Yeah, really interesting. I think there are a lot of examples of that we're not even aware of the kind of the integration of the Internet of Things. Can you expand on that a little bit, Tim? Maybe give us a couple of examples of the ways that the IoT is actually perhaps more reliant than we even realize on solid connectivity.
Yeah, well, I think it's a good example that Colin mentioned there. So we had a client that had this problem where there was quite a high profile CEO was trapped in a lift in a building, and the emergency call button was running on a mobile SIM card that basically didn't have any connectivity. His mobile phone didn't work. He didn't have Wi-Fi in there, so he basically stuck in the lift and couldn't get out and couldn't contact anyone for this issue. And you would have thought that the lift motor would have been hardwired to something, the lift emergency button, but it wasn't actually. It was relying on a connectivity SIM card, which is poor planning, but it just shows how it is everywhere, and everything is using it and relying upon it. So you've got a lot more smart devices these days. In industry, I was at a high-end engineering place the other day, and they've got incredibly impressive 3D printers and CNC machines, and there's a huge amount of data being shifted to these devices. So they're all online. All the design documents are being sent. All the feedback of how that process is going is all being uploaded to the cloud. And it's building management systems these days. All of the temperatures for the buildings, how all those systems are doing, how all the power systems are doing, is all the expectation these days. Is that all of this data is available online, and that people can have remote connectivity. So that's the massive difference. And when you don't have that connectivity, people just expect it to work. And so when it doesn't, it does cause problems. Which is why the resiliency.
Yeah, I mean, that's an interesting theme which has come out a couple of times. You've mentioned is the idea of expectations and how that's changed over the last couple of years. Colin, can you tell us about the ESN, and the emergency services, and what the implications are for businesses? But perhaps you can start by just outlining what actually we're talking about here.
Sure. Yeah. Well, the ESN is the Emergency Services Network that's being delivered by the Home Office MCP program. Although there have been one or two delays in the introduction of it, it is a system that will support emergency workers such as the blue light services, and is a system or a solution that will replace the current airwave system due to critical needs of data applications. There is a general consensus that the mobile network will be able to deliver that in a way that will lead on from what the airwave system has provided to date. But the Emergency Services Network will run over the EE's 4G and 5G networks. So what that basically means is that obviously buildings or certain buildings will need to ensure that there's a reasonably good level of 4G and 5G services to support the emergency service workers. You know, I mentioned the blue light services when they enter a building. So there will be a requirement for, as I say, those buildings, those environments to have support for that. We talked about hospitals as a good example where emergency services works. You've got fire stations, you've got police stations, and other public sector buildings where there will be a reliance on good mobile connectivity for that.
Interesting. So that's going to be mandated across the board, is it, for public buildings?
For certain, yes. There will be a strong case for a lot of public buildings to have sufficient ESN coverage. Perhaps not all public sector buildings, but certainly a large proportion of that. And obviously where the blue light services and the emergency services will operate, yeah. Hospitals and NHS, where NHS staff operate, and as I say, mentioned where ambulance, fire, and the police services predominantly operate, as well as air services as well. So those organisations will, as ESN comes in, or prior to coming in, there'll need to be a review and checks of those buildings to make sure that both across the floors and underground there's sufficient level of ESN coverage available.
Do we know when that's likely to be?
I think the current timelines is it should be launched and implemented by 2027. There's been quite a lot of R&D and development work around that, but I think the latest timelines are it's looking at the moment that it'll be a sort of 2027 launch onwards from there. Yeah,
okay, yeah, really interesting. Yeah, Tim, we touched on sustainability before, but I think this is another really interesting area. We talked about EV charging points, but I'm wondering, if you could, there's a kind of synergy, we were talking about previously about between connectivity and the kind of transition towards the green economy. And I wonder if you could.
I mean, it's one of the interesting things. It kind of links to the IT sort of world. Everything being connected. We've got a lot of green technology and green energy generation that isn't the same as sort of conventional, traditional energy generation in terms of the demand. So having a smart grid is much more important. So having all EV chargers, cars, electric vehicles can charge, when they want, essentially, if they're plugged onto the grid. So, the idea of having a smart grid is that demand can be managed to match with the supply. Up in Scotland, and our partners up there have worked on a lot of green energy solutions, getting connectivity out to wind farms and to remote hydroelectricity. The wind and power, looking out my grey low cloud view out there, there isn't a lot of solar around at the minute, and the wind power is zero. So hydroelectricity, the demand is instant response demand. So having people's homes connected to allow for that adaptability of the grid is going to be key for green technology. I mean, I was part of a trial here where you were getting text messages from the grid asking you to increase or decrease your usually decrease your consumption based on demand, to see how reactive people could be in real time to grid fluctuations, which is very interesting. I've got solar power on my roof and battery backup systems that I work with a lot, and it's interesting how those can be used to facilitate the best use of green power, and therefore the green revolution, which is very interesting. I mean, I think there's always a drive to make the actual equipment itself also more efficient, which it's very low consumption of power market, which is great, but it's mostly about what it facilitates. You try and charge your electric car in a basement car park using an app. Everything is app based these days. If you have an electric car, you have to have the pain of downloading about 25 different apps every time you you try and charge your car, and if you don't have connectivity, that's impossible. I think that it's a real issue in that world. But yeah, I've done a load of EV charging points, which are underground car parks and remote petrol stations, and yeah, that's to facilitate the users as well as the machines themselves.
I mean, I was in Frome yesterday for a meeting, trying to park, never mind trying to charge my car. And oh my goodness, I was tearing my hair out at not even being able to connect to the Ringo app. It was it's a flawed system as it is at the moment.
Yeah, I mean, I think just in town where I live here, there's 4 different like app-based or phone-based ways to pay for parking. It's just so ridiculously yeah. So yeah, connectivity is key in that, and it saves a lot of phones getting smashed by the sheer frustration.
But I would add to that as well. I mean, obviously with building regulations and standards have evolved over the last number of years, with, as Tim said, the greener type buildings are energy efficiency in mind. So the materials that have been deployed, particularly in new builds, with that in mind, have obviously allowed buildings to become more energy efficient and reducing heating, electricity bills, etc. But what that's proved, or what we're finding and have found, is that's had an inverse effect on the mobile signal from the towers penetrating into the building. So we've seen, certainly in the last 4, 5, 6 years, increasing number of builds, particularly new builds, even glass-fronted buildings where you could be on the top floor, you could be looking out and actually visibly seeing the masts, but the masts and the towers, but you look in your phone in the building while you're sat there and you've got no signal, and you're wondering why you've got no signal. And a lot of that is down to the building materials blocking the signal, or certainly blocking it from getting into deep into the core of the building. So I think as buildings continue to evolve and there is a drive to reduce carbon emissions and improve efficiency, we will continue to see these issues, a lack of mobile connectivity. So obviously, building owners, landlords, building consultants, have to take this into account, which is today, I have to say, the mobile connectivity side of things has often been overlooked. It's been missed off building specifications. Yes, they may have looked at things like Wi-Fi. They'll obviously look at fiber connectivity and elements of that, but the mobile connectivity, which we've said plays a key part in everybody's life, including business, is missed off the requirement on new builds. And it's only at the point of tenants and people moving into the buildings and not being able to make phone calls do the alarm bells start ringing, and then everybody scrambling around, looking at where was it included, why was it not included, and what are we going to do as a next step to resolve it.
So what are the implications then for developers, where we talk about bringing these considerations into a much more kind of upstream, earlier stage in the planning process for new buildings? What would you say are the primary considerations for developers in ensuring that the infrastructure they're laying down now is future proof for the next 20-50 years? Yeah,
I mean, it's one of the elements that's, I guess, supporting that is there are new building standards being introduced and adopted that actually drive connectivity and audit connectivity. Things such as wired score that's introduced throughout the UK and Europe and wider, smart score buildings. So buildings are being scored on their connectivity, and mobile connectivity, mobile signal can and does play a part of that. And what that really does is encourage landlords and building owners to assess their mobile coverage. If it's a new build, then obviously the in-building penetration, really, you can't get a true assessment until arguably it's a sealed building, or until fix one is done, where the building's got 4 walls up and the windows are in, and it's effectively a sealed building. At that point, really buildings should be surveyed to understand what the penetration is like. What is the 4G? What is the 5G coverage at that stage? And that gives the landlord, the building owner, even the tenant, a good indication as to what the coverage is like and where any improvement is done. Now, importantly, at that stage, once a building is sealed and you get a true reflection, often at that stage, the ceiling tiles, the cable routes are still available. So there is the option at that stage to run in the cabling across some of the floors, put in the backbone infrastructure that would future-proof the building. So even at a later stage, when the building is fitted out and divided up and fitted into how it would be for a tenanted building or for the user of the building, then a further assessment could be done at that stage to understand, how poor it is in more detail, what level of equipment would be required. But importantly, George, at that stage, the cabling, a lot of the infrastructure would be done, and the fitting of a solution into key areas or all areas would be much simpler and arguably be much less costly at that stage. So I think the key thing is for building owners, even architects, really for new builds, mobile connectivity, mobile signals should be absolutely factored in as a prerequisite, not just an afterthought or a nice to have.
Yeah, I mean, that makes an awful lot of sense. Tim, one thing we talked about was, I'm going to wrap these two up together because I'm just aware of time, but I think two of the things which organizations are very aware of is security and particularly resilience as well. And we were talking before about how important, and that again maybe the kind of differentiation between Wi-Fi and cellular calling. And I'm wondering, if you could just kind of expand that, thinking about how, going back to me as a CEO of an SME, the considerations for me, in terms of the security of my digital security of my organization and the resilience as well.
Sure. Yeah. I mean, we're talking a lot about resilience, understanding what that is. Basically, if you've got connectivity, if, for example, there's a fiber strike, for example, one of the ISPs I work at, on Tuesday, we had a building site that's dug up a load of fibers, which were a load of BT fibers and a load of our fibers as well, and that basically there was about 10,000 customers connectivity that ran through those fibers that what community fiber we're using. Fortunately, we had other fiber routes that picked up those that kept those customers up basically. But if you're thinking about the incoming connectivity to your building, you're only going to have one cable as a rule, unless it's been specifically designed. And even if you've got multiple connections, it's probably coming into the same location, the same basement. So often if you have a fiber strike or a duct strike, that takes out the connectivity of the building, and then you don't have any connectivity in a conventional way, so your Wi-Fi is down. So then if your mobile connectivity is down as well, your business is basically shutting down if it relies on doing anything online, which all businesses these days do. So that's why it's great to have diversity of connectivity. You've got wireless data connectivity. There's a lot of low Earth orbit satellite stuff, the Starlink stuff, which basically it's running through different infrastructure. Not everyone knows, but basically the BT ducts or open reach ducts that are out on the street, that is what almost all of your ISPs are using. BT uses it, Community Fiber, GigaClear, City Fiber, they're all running through the same ducts. So if someone digs that up, you can take out a lot of the infrastructure. And there was an example where there was a fire in Telehouse North, I think last year, and that took down a lot of IT. It took down a big part of BT, it took down a big part of Sky, it took down some TalkTalk. So that made national press, and that was just a simple fire from a power supply, and that because that's a meeting point where all of these carriers are running through, you haven't got resilience in that thing, and all those customers were disconnected. I mean, not having connectivity in that sense can be a serious security threat. And yeah, that's why we always try and encourage our business customers, especially, to have diversity and resilience in their connectivity as a backup. For security, for the systems we put in for the Cel-Fi systems, they can be in completely standalone infrastructure, so they don't have to touch the existing IT equipment. For a lot of the banks that we've worked with recently, the IT team just don't want you to touch their IT infrastructure if you can help it. We use Ethernet cabling, but essentially the Cel-Fi kit and Nextivity kit has a different clock speed, so it can't actually run through conventional Ethernet switching. So it can be totally standalone. It uses Ethernet cables, but it doesn't have to run through through any of their connected devices. For our cloud management, we do like to have it connected to the internet, but that again can be a standalone system, either a copper line that's coming in, or through a 4G router is our conventional way of doing it. And it allows also users to authenticate using a separate device, which is quite important these days. Everything's got two-factor authentication. So if your mobile phone doesn't have connectivity, you might not be able to sign into your devices or apps. And yeah, I think that's my main considerations coming to security. I think Colin's got some great examples about how a lot of businesses these days, they really lock down their users' devices. So trying to connect to public Wi-Fi just isn't possible for a lot of people's business mobile phones. So therefore, if you're in a place that hasn't got connectivity, you're actually stuffed to get on to business systems and get online, which can be really frustrating, but also is forcing people to use public Wi-Fi is forcing them onto an unsecured network, whereas the mobile device and the mobile carrier networks are considered a very secure form of communication.
Mm-hmm. No, that's a really key point, I think. I'm aware of time, but I think bearing in mind we're talking about future-proofing, we're talking about forward-looking, forward-gazing. I think it would be somewhat remiss of us not to touch on 5G. So I wonder, Colin, if you could just give us a little soupçon of how businesses should be preparing to kind of leverage 5G and the benefits they could expect.
Yeah, I think one of the key things about 5G is high bandwidth, fast data speeds, almost at the point of the speeds that you see with Wi-Fi, even beyond. So I think certain businesses would need to understand what their applications are, what their demand is for high bandwidth applications, and be able to obviously take advantage of 5G when it's available, either as a backup, as Tim had said, to any sort of wireless infrastructure that they have in place, or even as their primary mode of connectivity. High bandwidth, non-standalone 5G may support their need, and therefore potentially the requirement to have 5G and Wi-Fi in some environments for some customers may not be required to have both. That it may be today from a data point of view. So I think it's really understanding what you need as a business. If you're a business that doesn't rely on high throughput, high bandwidth, over a continuous period of time, then you may not, high bandwidth 5G, private 5G may not be something you require, and 4G, basic 5G would be available. But if not, if it's something that you need high bandwidth for, fast data speeds, then understanding how best that can be delivered is something that you need to review, whether it's private 5G, whether it's 5G from the mobile networks that are broadcasted and then relayed into the building. But it gives huge potential. And as I say, with with ever more devices coming online in buildings, providing, sending and receiving data, there is an increasing demand for more data. So 5G, as it is rolled out, will be able to cater for those demands.
Fantastic. Well, thank you very much, fellas, for that discussion today. I'm wondering, I'm going to invite everybody in our audience if they have any questions. If you want to pop them in the Q&A. I've got one here from previously that I just wanted to start with, was actually something you were talking about just then, Colin. What is the interplay between Wi-Fi and signal boosting like Cel-Fi? Is there a risk of one interfering with the other?
Not from not from a signal enhancement point of view, a signal boosting point of view in its traditional way. Remember, what a system like Cel-Fi does in its classic off-air repeater mode, is that we're drawing the signal in from the outside. We may be amplifying it. We may be providing a level of enhancing and cleaning up of that signal, and then distributing it. But we're relaying. We're not creating a new cell in the building, and those frequencies that are broadcast outside that were brought in are at different frequencies, different bandwidths than Wi-Fi. So we talk about peaceful coexistence with even if your building, so if your building had very good mobile connectivity, and you put a Wi-Fi system in the building, it would be the same if you were putting a Cel-Fi system in, because effectively we're relaying the external signal inside, which exists today. So Wi-Fi is on different frequencies to the mobile signal, which is amplified and enhanced by cellular, different frequency. Both work in tandem without any interference.
Mm-hmm. Go on, Tim. You're gonna come in on that one.
Well, I was going to say that the mobile carriers have paid an awful lot of money for that piece of that slice of the spectrum. So in terms of radio frequency, that piece of frequency is well policed. Ofcom have funding to make sure that no one in the country is interfering with there's the 3G and 4G auctions were billions of pounds raised by the government for that spectrum, so that it is guarded, and obviously Wi-Fi devices, mobile devices, are built specifically to be within those standards and within those frequencies and to interoperate with each other. And what you're creating, as we talked about earlier with the building materials, Kingspan is a classic one where it's got 2 layers of foil on either side of the insulation, and then plus you've got walls. So you're actually creating a Faraday cage, and the modern sort of the latest 5Gs is running at higher and higher frequencies to get this higher data speeds and the lower latencies, which is the key thing with the 5G, and that is blocked even better by these new materials, because the higher frequency penetrates less, lower frequency, you think about long wave radio, transmits further. The more reliance on the 5G is actually going to cause a bigger need for these for repeaters, essentially. And Wi-Fi doesn't have this low latency, which the 5G networks and systems do. So the example of self-driving cars relies on very low latency data, whereas most people in the office, you're not going to have your self-driving car in your office, but there are devices that are going to require this kind of connectivity, and the expectation is that it'll be there, which Wi-Fi is not going to provide in the same way.
Okay. I've got one last question, and that's around actually the longevity of these products. I'm going to come to you on Colin, because we sort of touched on this a little bit before, but I'd be interested to get your take on it. Must be something you get asked from your clients. How do you approach that question?
Yeah, I mean, obviously people, if they've identified a problem with they're building and the lack of signal, and they're looking to invest reasonable sums of money. They want to know how long, what's their investment, how long will the solution, and what's arguably the return of investment. We normally sort of suggest that the product's lifetime sort of 10 to 15 years. In terms of an overall solution, and you may say, well, where does that number come from? Well, it's really in relation to the how long the Gs have been around, and been around in evolution for. You think of 1G, started off, then 2G, and obviously we're 3G up to 4 and 5G. Each version of each iteration of the mobile G series being around for 15, 20 years. You think 3G was auctioned in 1999, and that's only been sunsetted now, 23, 24 years later. 4G is probably the main mobile carrier technology at the moment. That was launched 2010, and we're 14 years and it's still the main carrier. Yes, 5G is coming in. It will start to take over, but as I say, when you look at 2, 3, 4, and probably 5, you're looking at 15 to 20 years of that technology being around. And with our products supporting 4G and 5G, we've got that longevity with the product to say that while 4G and 5G exists, which, as I say, expect to be for the next 10, 15 years, our products will be able to relay that signal in buildings for users. Yeah.
Well, it's a solid decade and a half of investment right there then.
I think so, yeah.
Excellent stuff. Okay, well, we'll wrap things up there. We'll bring things to a close. My sincere thanks to Colin Giles and Tim Rogers. As I said, if you'd like a little bit more information about what we do, pop on over to connectionsolutions.net. We will be running some more of these webinars in the new year, and we'll circulate the transcription, the recording in due course. So unless we have any closing remarks from our panelists.
Thanks very much for attending. Much appreciated.
Wonderful. Wish you all a happy festive season. Bye-bye.
Thanks, George. Bye-bye.
Cheers.